Hi there. This short video will illustrate a brief history of the evolution of principal component analysis and will discuss its relevance in modern day analytics. It is hoped that this video will enable the non-technical user to gain deeper understanding of a useful analytical technique. So, what is principal component analysis? Principal component analysis, more commonly known as PCA, was originally derived in the early 1900s by Karl Pearson as one of the popular techniques in multivariate analysis. Put simply, it is a technique used to analyze a specific quantity of data and examine the relationships which occur within the dataset of information. Its relevance became accelerated through the evolution of the computer and is now widely available on several statistical packages.
PCA is a technique that allows its user to gain meaningful results from large data sets by compacting and compressing the data. It often helps to comprehend uncorrelated variables obtained and reduce this information in an easy-to-understand and simplistic manner. For example, much of today's leading companies collect large amounts of personal data about its customers. Organizations are inundated with vast amounts of data continually. Deducing patterns from these forms of data is a distinct challenge that analysts and planners encounter. Numerous corporations rely on database management systems to identify marketing patterns. However, these searches can be time-consuming and use a significant amount of CPU. PCA offers a cost-effective and efficient alternative to analysis and interpretation of data. Furthermore, it enables a researcher to formulate improved projections. By decreasing a larger dataset into a compact number of variables, a researcher can identify previously concealed structures and patterns. PCA is utilized in numerous industries and diverse sectors, such as medicine, signal processing, marketing, and within the computer gaming industry.
To demonstrate principal components analysis, we will use a dataset from this study. The data comes from a public database and contains credit information about 1,000 loan applicants.
We are going to evaluate this top row of data. I'm going to explain how to interpret this data. Each of these numbers represents a unique value for each category. Some of them are simple numeric values, such as duration in months of account and credit amount. Others are nominal values with associated labels. This allows for the easy storage of information with limited characters. I'll use a few examples to explain this method. A denotes that this is a nominal piece of data. 4 represents the category and 3 represents the specific description. In this case, you can see that 4 represents the purpose of the loan and 3 represents the specific description, in this case, the use of the loan.
Now that we understand this data, we can load it into SPSS using the Read Text Data tool. I've saved it as a text document, and we can follow the steps of the text import wizard prompt. In this case, the default settings are appropriate, so we don't need to make any changes. Now that the data is loaded, we need to convert it from string format to numeric format. To do this, we will use the Replace tool. In the first column, we need to remove A1, as A is the attribute label and 1 is the specific category of the attribute. We'll replace it with nothing, leaving only the last digit. We will repeat this process for each variable that has an A and a category number. Eventually, the data will look like this data set. In this case, I've added labels and I've changed the variable to numeric format rather than string. We are now ready to begin a principal components analysis. To perform PCA in SPSS, go to the Analyze menu, Dimension Reduction, and Factor. Add all of your variables to the right column. In the Extraction section, you can see that the default method is principal components. Click Continue and click OK. In the output window, you can see the results of the PCA. The PCA found 5 components that explain the variation in the data. In the cumulative percentage column, you can see that these 5 components are able to explain over 50% of the total dataset variation. This means that we have reduced the dataset by removing variables that are not necessary. The dataset is now simpler, making it easier to visualize and manage. This example highlights the primary function of PCA, which is to reduce a dataset into a small set of key components without decreasing the accuracy of the data. We hope that you have enjoyed this video. Bye now.